we're going to be learning if and switch in Go. We'll start out by looking at the basic syntax of if statements. Then we'll get our hands on with some basics and we'll dig a bit deeper. Once we're good with if, we'll look at switch case. And again, we'll cover the syntax, get our hands on and dig a bit deeper. Finally, we'll round out the module with how to use if to handle errors, and then we'll do a recap. Well, let's get rocking and rolling. Okay, the humble but immensely powerful if. And let's just bust some jargon here. If statements let us evaluate conditions, and based on whether or not that condition is true or false, branch out and execute specific code. So yeah, like we just said a second ago actually, if a person is 18 or over, execute whatever, code A, yeah? Whereas if they're younger, execute code B. Now then, on the jargon front, we are evaluating conditions, and that's where the term conditionals comes from. As well though, you might hear the term branching. Well, like I just said, if a user is 18 or over, branch out onto the orange code here on the slide. If they're younger, we branch to the blue. Okay, the if statement evaluates true or false conditions. And if you like your jargon, I'm talking Boolean true or false. So, that means using Boolean operators. So we're not talking just a string here with the words true or false in it, or, I don't know, even an integer of 0 or 1 representing true or false. No, remember, Go is really strict when it comes to types. So we'll be dealing with Boolean true and Boolean false. And look, we'll see it in a second, so don't stress. Well, okay, for the syntax, first up, we've got the if keyword. And yes, it is case sensitive, so always lowercase. But then after that comes the expression to evaluate. And like we said, this can be anything that evaluates to either true or false. So like we said, again, is a user 18 years or older? If they are, do this. If they're not, do that. Other examples. Oh, okay. Is free disk space more than 10 gig? If it is, carry on. If it's not, throw an error. Hopefully you get the picture. Okay, then we need a set of curlies. And like I just said with functions, they've got to go here. Do not be going and putting this first one on its own line. If you do, you'll just make the compiler grumpy. And actually, on that note, now, this doesn't really matter, so don't let it mess with your mind or anything. But the reason behind all the strictness with the placement of curlies, well, you know how in some other languages they make you terminate lines with semicolons? Well, guess what? Go actually does as well. Only Go's really nice and the compiler does the semicolons for us. So, if you throw your opening curly on its own line by accident, the compiler's going to throw a semicolon up here and it's going to break the program. But who cares, right? I don't know why I even said that. Anyway, look, we put the code that we want to execute inside the curlies. And that's a basic if. That block of code will only execute if the expression here evaluates to true. But you can do else if and else branches, and we're about to see it all in action. But that is the basics of if syntax in Go. Whew, let's go see it in practice. Alright, we've got this framework of a program with a couple of variables declared and initialized. Actually, the code I'm using is in the conditionals folder of the course's GitHub repo, and it's called if.go. I know, really creative. Anyway, this first variable here is showing the length of my Docker deep dive course in minutes. And then this one is showing the same for my containers on AWS wavelength course. So Docker deep dives, like, I don't know, what is that? About 4 and a bit hours long, but containers on AWS wavelength, whew, only half an hour. So entirely different beasts. Okay. Oh, actually, remember, Go can infer types, so it knows both of these are integers. Anyway, let's throw in a simple if block. Alright, magic. Like we just saw, we start with the if keyword, and we're evaluating whether Docker deep dive length in minutes is greater than containers on AWS wavelength length in minutes. wavelength length. Anyhow, like I said before, we use Boolean operators like these I'm showing on the screen to do the actual evaluations. Well, obviously, this time we're asking, is the length of Docker Deep Dive greater than the length of containers on AWS wavelength? If it is, execute this code here. Okay, well, magic. But what if it's not? Or actually, what if they're the same? Well, this else if here uses the equals operator in case they are the same, and we use double equals here so that Go doesn't think we're assigning a variable a value. Anyway, it executes this line here, and then we've got an else on its own that basically says, if none of the above are true, run this code here. Now, it's a no-brainer. I get it. Docker Deep Dive's obviously longer, but no harm seeing it in action, and remember, save any changes you've made. Okay, mine's called if.go. And there we go. Docker Deep Dive is longer than containers on AWS wavelength. Whew, okay, I'll tell you what, let's jump back here and we'll have a step through. We've got the usual blah 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 at the top that I'm hoping we know by now. We're declaring a couple of integers as variables here, one's way bigger than the other. And then we're running this line that says, hey, if Docker Deep Dive's longer than containers on wavelength, which it is, run this code here. And because that expression was true and it's code executed, program flow then skips right to the end here and it doesn't even bother checking any of the rest. And then because we've got no more code in the program exits with a 0 return code indicating a success. Fabuloso. But what if Docker Deep Dive wasn't longer? Like, what if the variables were like this? Well, looking at the code, it's pretty simple. We come into the if block. Is Docker Deep Dive length in minutes more than containers on AWS wavelength? That'll be a negative this time, Houston, so we skip here. Are they the same? No, that's also a negative. So we skip to this catch-all else statement and we execute this block of code. Well, I'm saying that's what'll happen. Let's give it a save and a try. Containers on AWS wavelength must be longer than Docker Deep Dive. That's the fundamentals of if in Go. But there's more. So up next, we're going to dig a tiny bit deeper with simple initialization statements. Okay, sticking with the same code, if blocks also allow simple initialization statements that are executed right before the expression gets evaluated. So, as an example, instead of declaring and initializing our variables up here, we can actually do it right here in the if block. And a reason we might do it this way is that any variables we declare here are scoped within the boundaries of the if block. So, they only exist while we're executing this small block of code, then they get garbage collected when program flow moves on. Okay, so let's get rid of these here and we'll declare them here instead. Anyway, look, when execution reaches here, we read it left to right, top to bottom. So we're declaring and initializing Docker Deep Dive length in minutes as 275 and containers on AWS wavelength as just 30. Then we're evaluating the expression, is Docker Deep Dive longer than containers on wavelength? And then everything's as it was before. So yes, it is longer, and we execute this code here and jump immediately to the closing curly. And I think I think I hinted at it earlier, but once any expression evaluates to true, and remember we go from top to bottom, but anytime one of them evaluates to true, we execute its code, but then we jump straight to the end and execute any code right below here. So it's not like we evaluate this one, oh yeah, it's true, we execute its code, then we evaluate the next one and the next one. No! As soon as any of them is true, execute its code and jump to the end. Also though, we can have as many else ifs as we want, but only one final catch-all else. And then I think last but not least, we can nest ifs within ifs within ifs within ifs. So just as a quick example, and this code's in the ifnest.go file in the conditionals folder of the course's GitHub repo, but we're evaluating this here. It's true, so we execute its code. But part of that code is another if saying, is the course over 4 hours long? Again, that's true, so execute this code here. And go on, just so you know I'm not lying, save any changes, and let's give it another run. And there we go. Yes, Docker Deep Dive is longer, but oh my goodness, it is borderline put you to sleep territory. But that's if in Go. Dead easy once you have a play around, but super powerful. Well, next up, switch and case. Right then, switch case in Go is a bit like if, so this should be nice and familiar. However, there are some important differences and we'll see them as we go. But first up, we'll nail the syntax. We start out with the switch keyword, and then just like with if, you can have a simple statement before the expression. And also, like we saw with if, any variables we declare here in the simple statement are scoped only within the switch block. So they get garbage collected once execution leaves the block. But as well, and I reckon you're getting used to this by now, but the placement of the curlies is once again and always vital. So the first one abso-freaking-lutely has to go in the same line as the switch keyword. Whew. Anyway, between the curly braces, we stick one or more case statements like this and an optional default block. And you probably guessed it, the default block is the catch-all that executes if none of the case expressions are true. Okay, well, to keep it simple for now, we won't bother with a simple statement and we'll go straight with a simple expression, Kubernetes deep dive. Right, well, Go puts that value in memory and then for each case statement, it looks for a match. Well, in this example, we match on the first case and we execute this block of code here. And then, importantly, and this differs from some other languages, but once the first case block executes, flow jumps immediately to the closing curly and it picks up on the following line. Now, like I say, some other languages have an implicit fall-through behavior, which is where once any case matches, all of the ones below it will execute as well. But that's not the case with Go. But I'm getting ahead of myself. Let's go see it in practice. Here we are then in a new code file called switch.go. And if you're following along, it's in the conditionals folder of the course's repo. And look at it, it's got a simple framework for a switch case. So in the expression here, we'll start out epically simple with just a string literal, Kubernetes. Now, obviously, this can be a variable or a call to a function or whatever, but for now, we're keeping it really simple so the focus is on what we're doing with switch and case. Anyway, Go's going to put that in memory. Then it's going to step through each of the cases looking for a match. So let's add these. Now, I'm being daft here, I know, but I just want to be clear. When it's looking for matches, it's got to be exact. So even though some of these might look similar, they're not. Only this one here is going to match. But as well, and this should be obvious as well, the types have to match. So we're comparing against a string. That means an integer or a float or a boolean or anything else is never, ever going to match. Well, tell you what, let's add some trusty printlns here to tell us which case matched. And by the way, it's totally okay to put the code blocks on new lines. In fact, I recommend it. Nice, readable code should be a top priority in all of our lives. Well, program execution's going to come in here and it's going to store Kubernetes with a capital K in memory. Then it's going to step through each of the case statements looking for a match. For me, this one's not going to match, so we should not see this text. But this one here, that is a match. So when we run it in a second, we should see this text. Case 2, Kubernetes with a capital kicking K. But then Go has no implicit fall-through behavior. So when it's done with that, it's not even going to bother looking at these below it. It'll jump straight down to here and the program will exit. Well, let's take it for a run. Oh, and don't forget to save any changes. And there we go. Case 2, Kubernetes with a capital K. And look, it's just a super simple example. You should definitely have a play around and try stuff out. Once you've done that though, and you feel like you know what you're doing, join me in the next lesson where we'll take a closer look at breaking and fall through. Okay, so we've said there's no implicit fall through in Go's implementation of switch case. And the reason for that is that each case statement comes with an implicit break. So in some languages, if you don't want fall through, you have to manually insert an explicit break. Well, with Go, it's the opposite. Breaks are in by default. So if you want fall through, you've got to manually insert one as the last line before the next case block. Probably best if we just see it. So we're obviously the same code here, matching on this one here that prints case 2, Kubernetes with a capital kicking K. But if we put a fall through here, well, actually, what do you think will happen? Do you reckon it'll run just the next one? Or do you think all of them will run? Oh, and what about the default block? Well, I'll tell you what, let's take a look. Okay, so obviously it ran case 2, but it only ran case 3, the one immediately following it. And if we look back here, yeah, look, we've actually got 4 cases plus the default block. So these didn't run. And you know what? If you think about it, that's right. Remember we said every case has an implicit break. Well, we overrode the one in this block with the fall through, so execution moved down to here. But when it finished, it hit the implicit break for this block and it jumped straight down here and the program exited. So, fall through only applies to the case statement it's part of, meaning if we want to fall through to the next level and the next and the next, we need a fall through each time. So, right now, this should run cases 2, 3, and 4, but hopefully not the default block. Let's have a check. Okay, yeah. But will it fall into the default block if we put a fall through down here? I guess only one way to find out. Yeah, there we go. So putting a fall through in the case above the default block lets execution drop into the default block. Okay, magic. But one last thing, right? To test the default block on its own, we'll put whatever up here, right? So we're no longer going to match on any of these cases. Well, save that. And there we go. We only got the default block. Now then, and please don't hate me for this, but it's more idiomatic in Go, and that just means more common, by the way, or more of a good practice, but it is more idiomatic not to use fall through, and instead just match multiple values in the same case statement. So to demo this, actually, I'll dial it back to this. The actual code's in a file called idioswitch for idiomatic switch, and of course it's in the conditionals folder of the GitHub repo if you're following along. Anyway, I'm importing a couple of packages here to help with some random number generation. But also, we're getting a tad more realistic here by switching on a value returned by a function rather than just some daft string literal. Well, we're declaring a new variable called tempNum and we're initializing it with the value returned by a function called random. So, down here, let's drop this code here in for the random function. And if you've been following along, you'll know it's taking no argument, but it is returning a single integer. Here we're setting it based on the current time to help with the number generation, and then based off of that seed, we're returning a random-ish number between 0 and 9. So, back up here, tempNum gets assigned that random number that's going to be between 0 and 9. So, in our case statements, let's do this. Now, each line is a comma-separated list that importantly matches multiple values per case statement instead of having loads of cases and loads of fall-throughs. Basically, we're branching on whether the number is odd or even. Well, as always, let's see if it works. Okay. Yeah, look, sometimes generating an odd number, sometimes an even. All right, time for one last look back at if, but in the context of error checking. Right, time for a quick look at how the if statement is commonly used for error handling. Now, there's other ways to handle errors, but what we're about to look at has been pretty much the way for the last, I don't know, forever. Basically, you'll see this in just about all code out there. And you know what? Error handling might possibly be the single most common usage of if in Go. Anyway, look, and I'm not sure if we've mentioned this yet, but it's idiomatic in Go for functions to return an error value as its last return. Like this function here that's testing connectivity to a remote host. So we've got the function name and its input parameter and type, but then two return values. And of interest to us is the last one. And yeah, it is of type error. So yes, error is actually a defined type in Go, just like we've seen with strings and integers and booleans and the likes. As well though, it's normal practice in computer science in general for a nil or zero error code to indicate success. And then anything other than nil or zero indicates an error. So if the function executes as expected, like it gets the input values and everything it needs, but more importantly, the function code executes as expected, then it returns a nil value and all is good in the world. But if something goes wrong, then it returns a non-zero code, like a 1 or a 2 or a 3 or whatever, right? And of course, it's normal to define different error codes based on the type of the error. And look, we'll see it in a second. Now then, of course, it's all well and good to write good functions that return error codes, but the onus is on us as developers to check for them and do something with them. And we'll see this in a second, right? But honestly, all good Go code consistently, like all the time, is checking for errors and acting accordingly. Anyway, what we've got here is a call to the open function in the OS package. Oh, and we're in the iferror.go program in the conditionals folder of the GitHub repo, yeah? Anyway, we're trying to open a file called test1.txt in my current directory. Now really quick, there are more idiomatic ways to open a file in the current working directory, such as the getwd or the executable functions, both from the OS package. But you know what? That'll just clutter this code and distract from what I'm showing. So I'm doing it like this. Anyway, the os.open function returns two values. We're not bothered about the first one, so we'll just ignore it with the underscore. But the last value it returns is an error code, so we'll capture that there with the air variable. And honestly, you are gonna see this here everywhere. But, and this is the important bit, we check that error code stored in the air variable, and if it's not nil, so if there is an error, we're gonna print it to the screen. Obviously, in the real world, we'd have some code here to catch it and handle it. But, because I want you to see what's actually in the error code, we'll print it to screen. Well, we'll save that and give it a whirl. I said this one was called iferror.go. And remember, you have to have saved any changes. But also, if you've cloned the repo locally, you will need to run it from within the conditionals folder. But there we go. And funnily enough, it threw an error. Who'd have thought? Well, this is the actual text returned by the open function in the OS package. And it looks like the file doesn't actually exist. Let's have a look. Ah, right. We're looking for test1, but it's actually just test. So if we jump back here to our code and make this just test, and as it's obviously going to work this time, let's put a copy of this println down here so we see what the return code looks like when it actually does work. Give that a save and a run. Okay, magic. An actual nil value, just like we said. So, we got this here when it errored out, and then a nil value when it worked. Well, I have been saying you'll see this kind of error checking all over the place. So, give me a second actually. Right, this here is the deployment controller package from the Kubernetes project. Meaning, Kubernetes is obviously written in Go. And actually, you know what? Most of the major cloud infrastructure projects are. So, Docker, Istio, Linkerd, obviously Kubernetes, and way more. All of them written in Go. Anyway, the reason we're looking at the Kubernetes code is that it is proper weapons grade production code. And if we search up here for if err, oh look at that, 20 odd references just in this package. And look, the second one down is pretty much exactly what we've done. If err is not nil, okay, and this is saying or if the length of the value in the deployments variable is 0, do this here. Basically exit the function and return a nil value. So I guess, yeah, a tiny bit more complex than what we've just done. But the point is, the code is literally littered with this type of error checking. So, like we said, very idiomatic. You know what? That's been a lot. So time for a quick session recap. Okay, I'm going to make this short and sweet. We started out looking at if statements and how they use Boolean logic to evaluate if things are true or false. The structure is basically, if something is true, execute the block below it. And of course, we can have as many else ifs as we want. And then obviously, if any of those are true, execute their code. And we round things out with a catch-all else that'll run if none of the stuff above is true. Well, we also said that as soon as any of the statements evaluates to true, and we evaluate them from top to bottom, but as soon as one fires as true, we run its code, but then program execution jumps straight to the end, so we don't bother checking the rest. Well, then we looked at how if is commonly used to check for errors. So, it is good practice for Go functions to return error codes as their last return value. And then we normally capture that in a variable called err, and then use it to say if err isn't nil, so it's not nil, indicating an error, run this code and handle it. Well, we also looked at switch case in Go, and the logic is similar to if, but it tends to be a shorter way of writing an if block without having to have tons of else ifs. Anyway, we evaluate an expression. The first case to match runs its code, and then it breaks to the end here. But if we want to run more of the case statements, then we can drop in a fall through and the next one will run. But only the next one. So, if we want them all to run, they all need a fall through. And I reckon that about wraps it. Again, practicing is vital. So, fire up your editor and play around and see if you can break it and figure out what works and what doesn't. And when you think you're good, join me in the next module, because we're looking at loops.